Hey Dad, you told me what energy is, but how could all of this be energy?
Okay, so what is energy? Well, energy is everything. Okay, if you take everything that we kind of understand, let's baryonic matter, that's everything made of protons, neutrons, electrons, that type of stuff, right? All right, that's only less than 5% of everything we know. Okay, everything else is dark matter, dark energy. They call them dark because they don't know what they are. And all of this stuff exists in space. All right, but regardless, all of it is just energy. Okay, so what is energy? What do we know about energy? Well, energy follows the laws of thermodynamics. Okay, and there's four of them. The zeroth law, okay, is the law of equality. Okay, if A is equal to B and B is equal to C, then A is equal to C. Okay, kind of goes without saying, but it still needs to be said. So they said it. All right. The first law is the conservation of energy. Energy cannot be created or destroyed, only change forms. It states that for every action there is an equal and opposite reaction. The second law states all isolated systems tend towards maximum entropy. Entropy is how organized a system is. Okay? Maximum entropy is complete disorganization. Okay? And the third law defines zero entropy as basically a system so organized it only has one piece. Energy interacts with itself using four fundamental forces. Okay? The strong, the weak, electromagnetism, and gravity. Okay, these are the four forces, right? But all of these forces are just different forms of one unified force. Okay, and that unified force comes from the second law of thermodynamics. Okay, where energy travels from high to low. Okay, so that high energy is actually attracted to the low energy. That attractive force is the most fundamental unified force, the only real force, and everything else is just a variation of that. Energy is fractal. Man's always liked using geometry based on circles and squares and curves, mostly because it's easy to think about and it's easy to do math on. But that's not the geometry of nature. Nature is fractal. Fractal geometry is geometry based on loops. How something changes throughout time is in the geometry. If you take a circle is a circle, and it'll always be a circle. It's unchanging and static. But nature and energy are movement and change, and you need a different type of geometry. With fractal geometry comes self-similarity. A fractal will look the same whether you are very close or very far. And something called the fractal dimension. It's not where ghosts live. It has to do with its roughness. This is a higher fractal dimension than that. The important part of something's fractal dimension is it's directly related to its entropy. And when we're trying to define something like energy that obeys the laws of thermodynamics, which are based all on entropy, well, it's obvious that circles just aren't going to cut it. So as a twig and branch become a tree, what would the smallest bits of energy look like? And when I say small, I mean really small. I'm saying let's blow a hydrogen atom up to the size of the visible universe. At this scale, we would be able to watch the interactions of these bits of energy on a movie screen. So we have our bit of energy. What is it? Well, energy is movement. And it would look like a wave. Think about a boat on the water. As it moves through the water, you get a bulge of water in front of it as it's being pushed out of the way. And then you have an equal and opposite hole, a dent, the wake of the boat, where the water hasn't had a chance to rush back in yet. So you can think of a bit as a area of higher than average energy density followed by an area of lower than average energy density. Now, the unified force says that the high energy will want to even out with the low energy. So there'll be an attractive force from the high to the low energy. Okay? But the first law states that there's an equal and opposite reaction. So as the high energy is attracted to the low energy is attracted to the high energy. This mutual attraction is called the strong force. The strong force is what holds particles together. Okay, so now we have a bit, the most fundamental of particles. And let's see how this moves through its environment. All right? To do this, let's draw a force diagram for the high side of the bit. First, it has its forward momentum, and then it has its attraction to its low side. And these two are in balance. Now, if space were completely level and flat, then it would just happily travel along in a straight line forever. But the truth is that space isn't flat. Space, in fact, is incredibly bumpy. So as the bit travels through space, it will be deflected off of high energies and attracted to low energies, causing the bit to change course. Now, once a bit starts to turn, its attractive force to its lower half causes a cumulative reaction. It acts like a rudder on a boat. The bit will just start turning tighter and tighter. Even if it's deflected the opposite direction, it just slows the rate of turn. So now we have a spinning bit of energy. It still has its forward momentum that balances with its attraction to the lower half. And it still has its wave-like structure. But not all bits are created equal. Some have higher energies and some have lower energies. Now, a higher energy bit has more forward momentum. Now, just like a boat on the water, the faster the boat goes, the more the bulge happens in the front and the deeper the wake gets in the back. So the more forward momentum, the bigger the difference between the high and the low sides. This is how the system stays in balance. More forward momentum also means that the bit is spinning faster. Spinning faster also means that it's bigger. To better understand the relationship between bit's energy and its speed and size, I like to think of a mass on a string, okay? Because you can separate them out. Now, when the bit's spinning, it's going around in a circle, just like this, right? And the more energy that you put into it, the bigger the circle is, okay? Also, if you spin it this way, okay, when I spin it this way, the circle doesn't get any bigger, so when I add more energy, it spins faster, okay? There also means when less energy means that it spins slower, okay? Now, a bit is somewhere in between the two. The more energy, the faster it goes, and the more energy, the larger it is. Not bad, huh?
Good thing you didn't hit me again. God!
Oh, don't go that way! Okay, so those are individual bits. Now let's look at the bits and their environment as a whole. Now, if the second law had its way, there wouldn't be any particles bigger than bits, and all of the bits would be roughly average the same size. This self-regulating property of energy is what I call the free energy density, or the FED. Now, free energy is disorganized energy. Energy that's free for particle formation. Think about a town that doesn't have any business in it. It has lots of people in it, but none of them have jobs. They're free, just like free energy. Now let's say that a new company comes to town, a particle, all right? And it starts hiring these people up. They didn't really go anywhere, but they're not free anymore. They've been organized, and now they work for the company. So the FED is the density of this free energy. Density is how tightly packed something is. And it determines the average energy of the bits. It's like when you compress air, it heats up. That's because less dense air, there's more room for the atoms to move around. So then as we compress it or increase its density, the more the atoms bump into each other. Every time the atoms bump into each other, they convert some of their movement energy into heat energy. But the energy of bits don't affect their temperature, they affect space-time. So let's talk about the fabric of space-time. They call it a fabric because it's all connected. It can be stretched and twisted, but has a tendency to be flat and uniform. This is because it's being regulated by the FED. The stretches and warps in space-time is how we perceive variations in the Fed. Now, the higher the Fed, the larger space is and the faster time is. Vice versa, the lower the Fed, the smaller space is and the slower time is. Now, they call it space-time, one word, space-time, because you can't change one of them without the other. And it's all because of the rotation of the bits. The higher the Fed, the more energy, the larger the bit, the faster the bit is spinning. I think it's time to talk about Legos. I like to think of particle formation like Legos. Now, you can build pretty much anything out of Legos, but it has its limitations. You know, Legos only fit together a certain way. Legos only fit together with Legos of the same type. You can't mix the giant Legos with the little Legos, right? And pretty much all the blocks can be simplified down to a single prime Lego piece. So if particles were Legos, a bit would look like this. And almost all other particles are made up of them. And then you can build whatever you want. Now, if I change the size of the bit, I change the size of the particles. And I change the size of whatever the particles were made into. It looks the same, and all of its pieces fit together the same. It's just a different size. Now, Legos fit together because of their interlocking shape, but particles fit together because of harmonics. Harmonics has to do with the way waves transfer energy. Depending upon their frequency, some waves will amplify each other, and some will negate each other, and some will pass by each other without even noticing that the other one's there. Since bits are spinning, they have a frequency, and the higher the energy of the bit, the higher the frequency. Looking at particles like this, it looks less like Legos and more like gears. More specifically, clock gears. That's because the higher the energy of the bits, the faster the gears turn, and the faster it seems time is moving. So that's space, the most primordial form of energy. Everything in the universe exists in space. Space is everywhere, in everything. It's made up of bits, the smallest form of energy. Space is the maximum entropy referred to by the second law. Just like all electricity wants to return to ground, all energy wants to return to space. And its density affects the size of space and the rate of time. Now, as particles exist in space, just like kids splashing around in the pool, they make waves. One type of wave that's created is called the standing wave. A standing wave is a wave that doesn't seem to move in respect to its environment. Standing waves are responsible for what we call the weak force. The best visual representation of standing waves comes from Chladni plates. The plate is covered in salt and hit with sound waves. When the sound wave is a resonant frequency of the plate, patterns in the salt will form. Now, when it comes to particles, the plate is space and the particle is producing the waves. So when two particles come within the weak force's influence, the highs and lows of their patterns can lock together. And this is how the weak force can hold particles together. But the patterns can line up all kinds of different ways. Most of the time there's some negative interference. That's where part of the pattern actually repels each other, like two north poles of a magnet that don't want to go together. If the negative interference becomes too great, the weak force will literally tear the particles apart. This is what we call radioactivity. Another type of standing wave is called the vortex, and it's responsible for what we call electromagnetism. Vortices are things like tornadoes and whirlpools. It has a structure that's similar to the weak force, but it has flow. Where the ripples of the weak force dissipate quickly, the energy flow of electromagnetism can link up and magnify each other, or completely repel each other like two fire hoses pointed at each other. These attractive and repulsive forces are well known to anybody who's ever played with some magnets. Now they call it electromagnetism because it came from the study of electric fields and magnetic fields, but they're really just two sides of the same thing. Now electrons, along with protons and neutrons, are electromagnetic particles, and they're called baryonic matter. Everything, all the stars, all the planets, everything here on Earth are all made of baryonic matter. Matter is anything that has mass and takes up space. For something to have mass, either it is a mass particle or some of its pieces are. And baryonic because protons and neutrons are particles called baryons. Since they have mass, somewhere inside of them there's a mass particle doing its business, just like the kids splashing around in the swimming pool. And they are just the vortexual turbulence of the splashing. Now when you flush the toilet, that vortex has flow in one direction. But EM vortices have flow in both directions. Flow in one direction is positive spin, flow in the other direction is negative spin. And systems like to balance. Now the mass particle engine that drives protons and neutrons is very, very similar. The difference is in the balance. A neutron would be an internally balanced engine as opposed to a proton, which would be an externally balanced engine. Since the positive and negative spins of a neutron are balanced internally, there's no external flow and no external magnetic force. A proton, on the other hand, isn't balanced. It has a positive spin and a positive magnetic force. This positive flow spreads out like a fractal framework, looking for something to balance with. The electron. Electrons are much smaller, much less energetic particles that act like the external balancers of protons. They can get taken off, they can get lost. That proton engine just keeps on turning, but it's not really happy unless it's in balance. Electrons have a negative spin. That's why they balance with the positive spin of the protons. Now when a proton and an electron connect, it's not like the moon going into orbit around the Earth or anything like that. Their frameworks completely intertwine. The electron's energy might be centralized in a particular place, but the electron's energy is constantly flowing throughout the entire framework. This gives the illusion that electrons can spontaneously hop from one place to another or even exist in two places at once. But it's just the electron's energy flowing across the framework. Now the framework has eddies, places where the electron's energy can pool. Now different eddies have different energies, and an electron will pool in an eddy that matches its energy. Now electrons can freely move to another eddy of the same energy. To move up a level, it must gain some energy, and to move down a level, it must lose some energy. When an electron loses energy and drops a level, the lost energy takes the form of a photon, light. A photon is a vortex ring. They're like smoke rings made of energy. Electrons gain energy through collisions from photons or something else. These changes in the energy of electrons is what we call heat. Temperature. The more the energy, the higher the temperature. Something else happened when that electron bonded with that proton. Hydrogen. Hydrogen is the combination of one proton and one electron. Now protons, neutrons, and electrons can combine into all kinds of variations and combinations. And these are called elements. Now protons and neutrons are very similar, so they have a tendency of getting stuck together with the strong and the weak forces. But protons will repel each other, unless a neutron gets stuck in between them. The neutron acts like a shield. These conglomerations are at the center or the nucleus of the atom. Now every proton should have an electron to balance it. These electrons are grouped in shells around the outside of the atom. But an electron shell is only happy if it's full. The only elements that are both balanced and happy are the noble gases. That means all other elements can only be balanced and happy if they're connected to some other combination of elements. These combinations are called Molecules. So the world we experience, the trees, the earth, the air we breathe, are all made of molecules and atoms. The light we see is photons, which are electromagnetic particles. When we touch something, when we feel something, it's actually the magnetic force of our electrons repelling the magnetic force of whatever we're touching. And we don't ever actually touch it. So there's only one last thing to explain.
I'm not touching you. I'm not touching you.
The mass particle. Mass particle is based on something called a self-magnifying loop. Self-magnifying loops are not isolated systems as they have energy flow into them, as opposed to the massless particle, which is an isolated system. To better understand the difference between isolated and non-isolated systems, I like to think of a kid on a swing. So let's look at this guy. With no energy flow into the system, he just sits there. So let's see what happens if we just give him a push. As he moves, his energy is lost to things like wind resistance and friction in the bearing. Because of this energy loss, the child will never get as high as his initial conditions. He slows and comes to a stop. This is the second law in action. Now let's imagine a kid kicking on a swing. This is a self-magnifying loop and not an isolated system because there is flow into the system. When the child's momentum has taken him to his highest point, by changing his body position, he raises his center of gravity. This adds energy to the system. This added energy balances the energy lost due to resistance. In theory, the child could swing like this forever, and it's powered by chicken nuggets. So how could a particle act like a kid on a swing? Well, imagine a system where every rotation, a small amount of the bit's energy is transferred into the rotation of the entire system. Just like every cycle, a small amount of the child's muscle energy was transferred into motion. But where muscle energy is replenished by food energy, bits energy are replenished from the space they inhabit. Since the bits exist in space, as they lose energy, the second law balances them. To better understand, let's map the energy flow of a mass particle. The energy starts in bits that enter into a self-magnifying loop. From there, it's transferred into the rotation of the entire system. Rotation of the particle transfers energy into turbulence in the form of the weak force and EM vortices. From there, the turbulence diffuses and the energy returns back to space. Space then balances the bits that started this whole mess, and the cycle starts all over again. The system includes the particle, its turbulence, and the space within its influence. Now, this system affects the free energy density of space. When the energy gets caught in the cycle, it's no longer free energy. So there will be a depression in the free energy density of space that matches the energy caught in the cycle. This depression in the FED is what we call gravity, and it's not much for one mass particle. But when you start stacking them up, it's a whole nother question. So a mass particle has its own gravitational influence, but it exists in space, and space isn't flat. The free energy density on one side of the gravitational influence will be higher than on the other side. That difference is what causes the force of gravity. To better understand, let's look at an airplane wing. Now, an airplane wing exists in the air, and there is an atmospheric pressure of about 12 pounds per square inch. Now, if the wing isn't moving, the pressure on both sides of the wing is the same, and therefore there's no lift. But as the wing starts to move, the air above the wing has a farther distance to go. This stretches the air out and lowers its density or pressure. If the pressure drops by 1 pound per square inch and the wing has 100 square inches, then now you have 100 pounds of lift. Now with gravity, instead of lift, we have weight. Weight is the difference in the free energy density times the size of the gravitational influence. Now pretty much everything we know about is made up of baryonic matter. which is made up of protons, neutrons, and electrons. Now, electrons have such a small mass that's almost zero. And protons and neutrons have almost the same mass, and therefore they just gave it the atomic weight of 1. This means an object's weight is dependent upon how many protons and neutrons it has. If I weigh 200 pounds and I have 200 pounds of gold, those two things are very different. There's different number of atoms, different sizes, everything. But it'll have roughly the same number of protons and neutrons. If I take my 200 pounds of gold to the moon, we still have the same number of protons and neutrons, but the force of gravity is less. The difference between the high and low sides is less, and therefore we weigh less. So the force of gravity is an attractive force shared amongst mass particles. It causes them to clump up. As they clump up, their gravitational influences are stacked upon each other. The more densely packed they become, the higher gravity becomes. Which brings us to gravity's loop. Gravity attracts. The system gets denser and spins faster. Gravity then increases and attracts more. To better understand the relationship between gets denser and spins faster, think about an ice skater. If the ice skater is spinning with their arms out, they're spinning slow. And as they pull their arms in tight, they spin faster. This is called angular momentum. So the ice skater's spin is a certain amount of energy. And as they move their arms in and out, that energy stays constant. Now with the arms spread out, the distance being traveled is much greater than with the arms in. So that energy gets spread out over a greater distance and you move slower. But instead of an ice skater, how about the Earth? It's spinning and has its own angular momentum, but it's part of a gravitational system. The system includes all of the mass and all of the space within the gravitational influence. It is in the process of converting the free energy density of space into rotation of the system. That means that space is spinning, and the more gravity, the faster space is spinning. Let's look at space from the bits level. Bit 1 is from outside of the gravitational influence way out there. And then we have bit 2 and 3. Now bit 1's energy is based entirely upon the Fed. It's under no gravity and it isn't moving. Bit 2 is under some gravity, so some of its energy has been transferred into rotation of the system. Relative to bit 1, time is moving slower, it is smaller, and it is orbiting the gravity well. Bit 3 is experiencing even more gravity, so it's given up even more energy to the rotation of the system. So it is relatively slower, smaller, and orbiting faster. But when you compare any three of them to their neighbors, they're not moving and the exact energy that they should be. Now, as I'm standing on the Earth, gravity is pulling me down, and I'm standing on the ground. So the electrons in the bottom of my shoes are repelling the electrons in the dirt. So that repulsive force is stronger than the force of gravity. This is what keeps gravity's loop from collapsing the Earth down denser and denser. Even at the Earth's core, the electric force of the iron atoms is more than enough to withstand all the weight of the Earth crushing down on it. Okay, so now let's walk up this mountain. For the angular momentum to stay constant, the Earth's spin will slow. But we also have to fight gravity. Gravity likes energy to flow from the free energy of space into the high rotational energies of the gravitational system. So as we go up, we're fighting this flow because we're actually transferring energy from the gravitational system into us. We're made of mass particles, and mass particles are made of bits. So as we move into a higher energy space, our particles have to gain energy to match the space. So we made it to the top of the mountain. The free energy density here is higher than it was when we started at the bottom of the mountain. Time is moving faster. Space is bigger. We're bigger. All of our particles have more energy in them, all the way down to the base bits. As we start to walk down the mountain, that extra energy is converted back into the rotational energy of the system. Now, if we were to jump out of a plane instead of walk down a mountain, the exchange in energy would be the same. We might not be in contact with the Earth, but we're still within the gravitational system. Even the moon is part of that gravitational system. And in fact, the Earth is just part of a larger gravitational system of the sun. Now, the sun is a star. Now, a star's mass and therefore gravity is so strong that something cool happens. Now, before stars, there were only two elements, hydrogen and helium. But inside stars, those elements get squished together so tightly that they fuse together, forming heavier elements. In fact, everything on the periodic table, all the way up to iron, is formed this way inside of stars. Everything higher than iron on the periodic table is made when stars blow up. These elements need the heat and pressure of a supernova explosion. Sometimes these explosions form neutron stars. Neutron stars aren't made up of atoms. A neutron star gravity is stronger than the electric force of the electrons and the protons. When this barrier is broken, the density goes way up. Just to put this into perspective, if an atom was the size of a football stadium, the nucleus of the atom would be the size of a blueberry. So imagine taking things the size of football stadiums and then make them the size of blueberries. And that's how much more dense a neutron star is to a normal star. And sometimes you get a black hole. Now, a black hole's gravity is so great that it breaks down all of the barriers all the way down to just the base mass particles. And without anything to stop it, it just gets denser and denser. And the Fed drops more and more. Now, each iteration, those mass particles require a certain amount of energy to sustain their reaction. In normal space, this amount of energy is very small, a fraction of the bit's energy. But gravity can lower the Fed to the point the bits of parts of the black hole is lower than the amount of energy required to sustain the reaction. This is where things break. Space is torn. If all of these pieces were gears, this is where teeth get stripped. Some pieces go from being a source of energy to being a drain, as the black hole struggles to keep time stopped in these bubbles of space. The process would send shock waves through the black hole. The release of energy could manifest itself as fast radio bursts in low-mass black holes or gamma-ray bursts in supermassive black holes, and jets in quasars. Now, all these moons and planets and stars and neutron stars and black holes exist within the gravitational influence of their galaxy. Now, the relationships between gravity and rotational energy is very well understood. If we know the distances and masses of things, we can calculate how fast they're moving. And our equations work good for things like planets and moons. But when we look at galaxies, we find that things are moving faster than they should be. We can see a certain amount of stars and things. But the gravity says there's more stuff there, more things going on than we can see. This invisible gravity-causing stuff they call dark matter. The first thing, black holes. Quite frankly, I think there's a lot more black holes out there than we give them credit for. The next I call harmonic perception. Remember how I said Legos only fit together with Legos of the same type? Well, imagine a family tree of particles, where particles only harmonize with particles of the same family type. So our particle family tree could be based on the number 3, but there could be another particle family tree based upon the number 2, or 5, or 7, or pretty much any of the prime numbers, up until a point. At some point, the energy density of the universe wouldn't have been high enough to actually produce any particles of a higher type. This is the closest thing in my eyes to the idea of a multiverse or alternate realities. But there could be complete galaxies with life forms and planets and all kinds of things going on right in the same space as us. And the only way that we would be able to perceive these other realities is the gravity that they would create. The final gravity adding ingredient is that any gravitational self-magnifying loop causes more gravity. It doesn't all come from matter. So let's look at a spiral galaxy. They last billions of years. This gives lots of time for isolated systems to die out. It also gives more time for self-magnifying loops to be created. But what would a gravitational self-magnifying loop look like? Well, it would start with a gravity wave, and spiral galaxies have a gravity wave. This gravity wave moves independently of the stars. We can see it where the stars are clumped together, the gravity is higher, and where they're spread apart, the gravity is lower. Now, it takes us 230 million years to go around the galaxy once. In that time, we would experience 2 cycles of the gravity wave from low to high, just like a kid on a swing. Now, a kid on a swing adds energy to the system by raising his center of gravity. Now, what if we were to do the same by timing trips up and down a mountain with the gravity wave of the spiral galaxy? Each cycle, we could add more energy to the rotation of the Earth, causing it to spin faster. But we would have to live a really long time, because each cycle is 230 million years. Mountains don't even last that long. But that's just about perfect time for solar systems to orbit each other. When 2 solar systems are orbiting each other, their center of gravity is somewhere in the middle. Depending upon their orientation to the wave, the center of gravity can be pushed one way or the other. If you time the orbit with the gravity wave, it can enter a gravitational self-magnifying loop that converts orbital energy into gravitational energy. So some of the dark matter doesn't come from extra mass particles, but matter interacting with itself to cause more gravity. Now, those galaxies are just parts of galaxy clusters, and the galaxy clusters all combine to create the entire universe. Now, the universe itself is a gravitational system. It's in the process of converting the free energy density of space into the rotation of itself. Now, space exists throughout the entire universe, but it doesn't exist outside of the universe. This means the Fed is always dropping, and as more time goes by, more systems enter into self-magnifying loops. This increases the conversion rate from free energy to gravitational energy, which brings us to dark energy. Now, according to NASA, dark energy takes up 70% of the amount of energy in the entire universe. But it's just a mistake. So here's the deal. There's a type of supernova explosion called the Type 1a. It's where a white dwarf is eating another star. As it eats, the white dwarf becomes more massive. Now, at a particular mass, that white dwarf will blow up, and it happens every time the same way, and gives off the same light. Now, have you ever heard a car horn as it drives by? Now, that change in tone is caused by the Doppler effect. Now, if something's emitting a wave like sound or light, while it's moving, the waveform is changed. If something's moving towards you, it squishes the wave, increasing the frequency. And if it's moving away from you, it stretches the wave out, lowering its frequency. Now, with light, if something's moving away from you, the frequency is lengthened, causing a red shift. And if something's moving towards you, the frequency is shortened, giving a blue shift. Now, when they started testing the red or blue shift of the Type 1a supernovas that they were measuring in distant galaxies, it looked like everything was just flying away from everything, as if the space between all the galaxies was expanding. And as time progressed, this expansion was increasing faster and faster. As we know it, all the gravity of those galaxies should have been pulling them all tighter together. So the amount of energy to push all of those things apart is tremendous. That's why dark energy accounts for 70 some percent of everything in the universe. But there's another reason why that light could have a red shift. When a photon is produced, its energy and frequency are based upon the energy of the particle that produced it and its speed and direction. Now, a photon is a massless particle. Over time, it will lose energy and its frequency will drop. And it will follow the curvatures of space-time because as far as it's concerned, it's still just going in a straight line. But since its energy is of a higher waveform, it isn't made of bits, and therefore its frequency is not affected by the free energy density of the space it inhabits. The only time the Fed does come into play is when the photon was created. Let's say 1 billion years ago, a type 1a supernova created a photon in a galaxy 1 billion light years from here. Now that photon's frequency was based upon the energy of the particle that created it, and its energy was based upon the free energy density of the space that it inhabited. So for the last billion years, it's been whizzing through space until it finally shows up here at Earth. Now, a billion years ago, the whole universe was spinning slower and the free energy density was higher. So now that the Fed is lower, that photon looks like it's too big. So the universe isn't expanding faster and faster. Things are just getting smaller faster and faster. And I mean everything. I'm talking all the stars, all the planets, all the galaxies. Everything is just getting smaller and smaller as its energy is being transferred into the rotation of the entire system. The reason this transfer of energy is speeding up is because as more time goes by, more systems enter into self-magnifying loops. But eventually star formation will slow down, there just won't be as many systems, and the transfer slows down. But there will be more black holes. If you're a mass particle in the universe, eventually you're going to end up in a black hole. So at some point, the universe will only be made up of black holes and space. And those black holes will just keep eating up that space. And the universe will spin faster. And the Fed will get lower, and everything will get smaller. And at some point, there won't be enough energy in space to keep the black holes fed. And the whole system will crash, spin out, explode, Big Bang, you know, that's it.